Alright, so let's start part 2 here. Got myself something to drink, ready to get started. Alright, Jose, member of the school's track team at their practice. Each runner ran 3 races and recorded their times. Which measure should be used if you want to find the spread of the data? The spread of the data. So let's put in some numbers. Let's just say one guy did it in 16 seconds, one guy did it in 18, and 19, 19, 20, 24, 26, and 52, because he fell down. Or he's slow, and he fell down. So which would show how much this data is spread. How much is this spread out? Well, if we say if it's spread out, we're thinking about what is the distance from our smallest number to our biggest number. And we think which of our measures talks about the lowest number and the highest number. Well, the only one that really makes sense there is the range. Okay? That's it. That's your answer. Range. We're done. Why it couldn't be these other things? If we talked about like the median, that would be what number is in the middle, and that's around here. And they're not asking the middle time. It's not asking for which time showed up the most, so it can't be the mode, which would have been 19. And it's not saying about how fast did each person go. So we're not talking about any sort of average. We're not talking about the mean. The only thing we're talking about is the range. Okay, that's it. Number 7. We've got a spinner with an equal chance of landing on red, blue, or green. So we can make a spinner here. Since there's only 3 colors, we split it into 3 parts. And we have red, we have blue, and we have green. And then we have a fair numbered cube, so we can draw one of those. So 6 sides on a cube, and it's numbered 1 through 6, so it looks sort of like this. And did you know, on a fair number cube, on the opposite side of the 1 is a 6, on the opposite side of the 2 is a 5, and on the opposite side of a 3 is a 4. Think about why that might be. Alright, let's do this. So what's the probability of spinning a green and then rolling a 1 or a 2? So there's 2 ways we can do this. The first way, we can make a tree diagram for this to make our entire sample space. So we can start with the spinner. We can say there are 3 different ways that spinner can land. It can land red, it can land green, or it can land blue. 3 different outcomes for that. And then when we roll our fair numbered cube, it can land anything between 1 and 6. So we can land on 1, it can land on 2, or 3, or 4, or 5, or 6. Okay? And if it landed green the first time, what would still be our outcomes for our spinner? Well, that wouldn't change. We can still get 1, 2, 3, 4, 5, or 6. And if we got blue, it would still be 1, 2, 3, 4, 5, or 6. So now the question's saying, what is the probability of getting a green? So we really only care about our green outcomes here. And we want to get a 1 or a 2. So one of these 2. So how many of our outcomes end up getting green and a 1 or a 2? Well, it's just these 2 outcomes, green and 1 and green and 2. So that is 2 favorable outcomes And how many possible outcomes are there? How many different ways can this turn out? Well, if we just count up all of these here, that's our possible. So 6 for red, 6 for green, 6 for blue. So that's a total of 18 possible outcomes. So what is our probability? It's 2 out of 18. We can simplify this if we divide both of those numbers by 2. Divided by 2. And we would end up with 2 divided by 2 being 1. And 18 divided by 2 being 9. So our probability would be 1 out of 9. Now there's a second way to do this that's a little bit less involved than having to write out the whole sample space, and that's just to look at each probability on its own. So if we say, what is the probability of getting a green? Well, that was 1/3, right? And then we say, what is the probability on our cube of getting a 1 or a 2? Well, on this cube, if our numbers are 1, 2, 3, 4, 5, and 6, that means there are 2 favorable outcomes. So that would be 2 out of 6. So what we have, just so we know, this is that was poorly drawn. Let's try again. This is the probability of getting a green, and over here is the probability of getting a 1 or a 2. So now if we take those two probabilities and if we just multiply them together, that'll give us the probability of both of them happening together. So if we take 1 times 2, we get 2. 3 times 6 is 18. And look at that, we get the exact same answer that we got doing the tree diagram. So either way you do it, the answer is 1/9. Okay, that's that. Alright, number 8. Point V reflected over the x-axis. What will its new coordinates be? We've done a lot of these now. Hopefully these are getting a little bit easier. That's not a straight line. Oh no. Go away. Let's cheat a little bit. My drawing is... I think I'm done drawing. Alright, so here's y, here's x. Let's plot our point V here. Our first point is negative, which is, our first point is always x. So if x is negative, it's got to be somewhere on the left side of our grid. And we say y is positive. Well, y is positive on the top side, so we need to be in the left and on the top. So our point would be somewhere around here. So here's V, and that is in quadrant 2, which is different from quadrant 1 or quadrant 3 or quadrant 4. So here's our point, and now it's being reflected across the x-axis, which means that this point is going to go from being up top, it's going to flip over this line, and it's going to end up coming down here. So here's our new V. So we have V prime, or the new V. And so let's see, how do those coordinates change? Did our x value change? Did this point move left to right? No, it didn't. It's still in about the same spot, regardless of how I drew it. So it's still, our x value is still negative 2.3. Oops. Negative 2.3, comma. Our y value did change. Our point moved down. We're now down in the third quadrant. All the y values in quadrant 3 are all negative. So 6.4 would have to become negative 6.4. So those are our new coordinates for point V. And there's your answer. Okay. Alright, number 9. Which figure has a congruent base? Congruent base. Remember, congruent means the same. More than just the same, it's same shape, same size. So let's see which of these will have same shape base, or same shape, same size bases. So let's draw a cylinder. Imagine that's a cylinder. And we have a triangular prism. Triangle, triangle, connect them, and a rectangular pyramid. And which of these have congruent bases? So we talk about bases. Our bases on a cylinder are the circles. Are they congruent? Yes. So cylinder is correct. How about our triangular? Oops, I forgot a side on my prism here. How about our triangular prism? The bases on a triangular prism are, you guessed it, triangles. Are those bases congruent? Yes. And let's give him some arms. One arm. Can't really see his other arm. And some hair. Yes, our happy little triangular pyramid does have congruent bases. How about our rectangular pyramid? So rectangular pyramid has this one base. So how can it be congruent if it doesn't have more than one base? That's impossible. This rectangle is not congruent to this point. So this becomes a sad rectangular pyramid because his answer is no. Oops. He gets double sad faces. No, not a rectangular pyramid. Okay, so prisms and cylinders do have congruent bases. Pyramids, cones, what am I forgetting? Pyramids, cones, and pyramids and cones don't have congruent bases. Okay, yes, no, yes, no. Alright. And number 10, draw the model for the square root of 16. Alright, that seems straightforward enough. Here is the square root of 16. And here is, why does it do that? Why is it erasing my body? Let's try again. Point, point, happy face. And let's give her, because it's a model. And not to say all models are blonde, but this model's blonde. Really long hair. And she is modeling the square root of 16. Look at that square root. And let's throw in a girl. And then the square root's like, I work out. Huh? Modeling. Get it? That's not funny. Let's do math. Model of a square root. If it's a square root, that means it's got to be in the shape of a square. A couple different ways you could do this. You could do it with dots. We need 16 dots, and they need to be in a square. So I can't put 16 in a row. I can't do 2 rows of 8. It's got to be even rows of dots. So it's got to be 4 rows of 4. Because that gives us a total of 16 dots. and it looks kind of like a square. Get it? Because it's a square root. And this gives us the answer. If you want to know what's the square root of 16 or what times what equals 16, it's got to be 4 by 4. Square root of 16 equals 4. I equals 4. Okay? Another way you can do this, if you don't like the dots, you can, you can draw better than that. We can make a square, and we can just break it into 4 rows of 4. 1, 2, I kind of like the dots better because my lines come out kind of shaky. But you get the idea. We have 16 little pieces of our square. It's still 4 by 4. It still shows that the square root of 16 is 4. There you go. Alright, so that is it. I keep forgetting to do this. I said I would give you at some point the answer to the bonus question from the quiz, which was, how do you get I don't even remember the question. We want 12 trees, and we want to make 6 rows of 4. So how do you make 6 rows of 4 using only 12 trees? If you don't want the answer, I would pause it right here. Okay, spoiler alerts coming up. Okay. Alright. Now, some people say it's tricky, and that's the point of it being a bonus question. It's not supposed to be easy. You would start off with 1 row of 4. Okay. And we can make well, let's just go with this. I'm going to take this, and I'm going to just say that's my 1 row. I also want to make a 2nd row like this, and I want to make a 3rd row like that. So that gives me 3 rows of 4. And so you're saying, well, where does the rest of it fit in? Well, just wait. Let's take another triangle, and let's go like that, and like that, and like that. And let's fill in the rest of our trees. So here's tree 1, 2, 3, 4, 5, 6, 7, 8, and where they intersect, 9, 10, and the top and the bottom. And now let's count the rows we made. We have 1 row of 4. We have 2 rows of 4. We have 3 rows of 4. We have 4 rows of 4. We have 5 rows of 4. And one last one, which makes 6 rows of 4. Using only 12 trees, each dot representing a tree, we have made 6 rows of 4. And let me take all this purple, because it makes it look kind of ugly. Ta-da! There is the bonus question. And we are all finished for today. Good job. I say good job. Go have some ice cream or snacks of your choice. You earned it.